Welcome to today's session. In this tutorial, we're tackling a fascinating challenge, building the shortest palindrome from a given string by appending characters to its end. This problem is practical in applications like data validation and algorithmic string manipulation. Stick with me, and by the end of this tutorial, you'll have a clear understanding of how to approach and solve it efficiently in JavaScript. Let's start with a clear understanding of the problem. The goal is to take any given string and determine the shortest palindrome that can be formed by appending characters to the end of the string. For example, if the input string is ABC, DDC, we are appending characters to transform it into the palindrome ABC, D, DCBA. Here's the JavaScript function that will help us achieve this. The build palindrome function starts with the input string and tries incrementally larger extensions to check if the extended string forms a palindrome. The inner loop compares characters systematically positioned around the center. If a mismatch occurs, the function continues extending this string until a palindrome is formed. Here's the step-by-step breakdown of this logic. We first start with a given string. Then we gradually extend the string by adding characters to the end. We then check if the extended string is a palindrome. A palindrome reads the same backwards and forward. Once the palindrome is identified, we stop and return the result. This method ensures that we only add the minimum number of characters needed, keeping the solution optimal and efficient. Let's take a look at an example. For the input string ABC, D, DC, the algorithm checks if it's already a palindrome. It's not, so it appends characters incrementally. First, it appends B, next it appends A. This process results in the shortest palindrome, ABCD, DCBA. Here's another example. For the input string 122, the algorithm operates similarly. The first character 2 is already mirrored at the start of the string. It appends 1 to the end to balance the asymmetry. The output palindrome is 1221. Examples like this illustrate how the logic applies to strings of varying lengths and complexities. Now, let's take a look at the ES6 version of our solution. This version uses modern JavaScript syntax for cleaner and more readable code. The for loop iterates through potential palindrome lengths. The inner loop uses array slicing and string manipulation to validate symmetry. The reverse method simplifies appending mirrored characters. The ES6 version does not change the logic, but makes the implementation more concise and easier to understand. Now let's consider the performance and edge cases. Time complexity. The algorithm has a quadratic time complexity of big O n squared because it iterates through all potential palindrome lengths and performs character checks for each. Space complexity. The space usage is linear, big O n, as the new characters are appended to the string. Edge cases. An empty string should return an empty string because it's trivially a palindrome. A single character string should return the string itself, as it's already a palindrome. Understanding these nuances is critical for applying the solution in a real-world solution. To wrap things up, we tackle the problem of building the shortest palindrome by appending characters to the end of a string. We walked through the algorithm, the code, and practical examples. We also explored an optimized ES6 implementation and discussed the algorithm's performance and the edge cases. This is a versatile approach that you can easily adapt for similar string manipulation challenges. Thank you for watching. If you enjoyed this tutorial, please like, share and subscribe for more JavaScript videos. I'll see you in the next one.